Introduction. First, importance of efficiency production, high quality, scalable process are critical in modern manufacturing, especially for packaging and storage component like lids and discs. Second, challenges of traditional method. Conventional technique often struggle with resource efficiency, customization and mass production demand. The third one is a role of automation technology. First, robotic. Second, pneumatic, and the third is conveyor system. Next, integration of automation. Focus on harmonizing robot, pneumatic, and conveyor system to create a seamless automation framework. Lastly, is key side. Examine system reliability, scalability, and flexibility in response to dynamic production need. Highlight benefit like improve sustainability, quality, and efficiency.
Actually, I want to give a quick demo about the existing system that used for the in-base production. So what we can see in this demo is when I started the starting, when I press the starting, the alarm siren and the warning light will click on for 7 seconds, and then it will emit the emitter to drop the material on the conveyor. So what happened here is this is a sensor at the entry that will trigger the robot to pick and place into the machinery. Then after the product is completed, the robot will take the material again and place it in the exit conveyor. So the product will go through this exit conveyor to the curve that conveyor, and here there will be a sensor, a vision sensor that will detect it by color and material. So for the vision sensor 1 is the sensor is detecting blue color, for the vision sensor 2 is green color, and the vision sensor 3 is the material of metal and black color, kind of grayish. So this will trigger this pusher, which is the cylinder, to push it into the remover, which we can see in a moment. So I will showcase the remover for now. Okay, the system is initiated by pressing the start button. So that one the one light will turn on simultaneously, and this will emit the material after 7 seconds. So this robot is currently picking up the material and placing it into the machinery. So what the machine will do is the machine will compress and press the material according to its shape. Once done, the robot will pick up it again and place it into the exit conveyor. So this is the green color. So what we can expect here is the cylinder number 2, which is the vision sensor 2. It senses the green color and it will pushes the material into the remover. So here we can see it will go to the remover. This is currently the setup that we can see in many of the factories. So now the machinery completed for the metal production. So we can see the vision sensor 3 will sense the material and the color, and cylinder number 3 will pushes it into the remover, and here is the place where the workers will clean out the completed product. Now I will showcase about the improved system, which we can see here. There is 2 numbers of cylinder only. Actually, I have eliminated the third cylinder and replaced it with the curved belt conveyor, so it can purposely drop the material into the box. So for another improvement is I have added the roller conveyor within the box, so that the product can be delivered by the roller conveyor from point A to point B. This will reduce the need for the workers. So from here we can see the design is completed for the improved version. And now I will initiate the program to showcase the demo of this version. So when I started the start button, the light and the siren will emit for 7 seconds, and then the emitter will start to emit the material. So from here we can see that the material is just emitted and goes into the sensor basis of the entry. So this will trigger the robot to pick it up and place it into the machinery. So once the machinery closes up, this material will be standby and then it will already go to the conveyor. So what you can see here is the robot is picking up the material and put it in the places at the exit. So this will go through into the conveyor, and from here we have the vision sensor 1 and vision sensor 2, but the number 3 is now it's not here. So the conveyor will pushes the material into the box. So we have another material here, which is the blue color. So the robot will pick it up and place it into the exit. So from the exit, the roller conveyor will go through all this conveyor into the vision sensor 1, which will sense the color and trigger the pusher number 1 to push the material. So we have a green color in the machinery now. So the machinery is doing its process. All the products on the conveyor, and you can see from the vision sensor 2 will sense, and the pusher number 2 will be triggered to place it into the box. Now the workers can use this metal box with the functionality of to trigger the roller conveyor to transport the product from point A to point B by using a manual transmission. And this thing can be stopped at any moment by using the stop button, and we can resume it again to transport it to the point number B.
This is the system existing design. When we press the push button, it will turn on the back conveyor, warning light and alarm system, and the timer will count until 7 seconds, and it will turn off the alarm siren and warning light. When the proximity sensor detects the products, the robotic arms will take the product and put it into the stamping machine. The proximity sensor 2 in the stamping machine will detect the product, and it will start the stamping motor to extend until it touches the limit switch 1. Then the limit switch 1 will turn on, and it will start the timer, and the timer will count until 3 seconds. The stamping motor will retract and touch the limit switch 2. The robotic arms will take the material and put it onto the bed conveyor. The vision sensor will detect the type of product based on the colors and material. And lastly, the product will be pushed by the pneumatic actuator. This is the control panel design for the improvement system. The initial system is the same, but the back has some improvement. To reduce cost, only 2 vision sensors were used in the system. So I will show the simulation. After the pneumatic actuator has sorted the product based on the color and material, the product will go into the container. The worker can control the roller conveyor to move the container by pressing the push button, and can stop the roller conveyor by pressing the stop button.
In this system, we integrate various components to automate lead and base production. For the input, the start button initiates the process, the stop button halts the operation, and the reset button reinitializes the system. The limit switch controls the extension or retraction of the pneumatic cylinder, while the vision sensor detects material color for sorting. For the sensors, the vision sensor identifies material colors, the proximity sensor detects nearby objects, and the retroreflective sensor ensures alignment, and the weight sensor checks if the boxes are full. For the actuators, the robotic arm handles material placement, the pneumatic cylinder controls stamping and pushing, and the motors drive the conveyor system. For the output, the warning lights and alarm provide feedback to operators. Belt and roller conveyors transport material, and pneumatic pushers sort item into the correct boxes.
Now I will explain the application, how the PLC system is applied to optimize the juicer industry process. The PLC system is the core of our atomic design for lead and base production, optimizing every step of the process. It begins by collecting inputs from sensors, like the color sensors at the sorting station, to determine whether a product is blue, green, or metal. Based on this, the PLC activates one of two pneumatic cylinders to sort blue and green products into their respective ranks. Metal products, undetected by sensors, simply continue along the conveyor. The PLC also controls the exit and roller conveyors, ensuring smooth transportation of products between stations, eliminating manual handling and increasing productivity. By replacing manual tasks with atomic precision, the PLC reduces labor costs, eliminates human error, and speeds up the workflow. Finally, its flexibility allows easy reprogramming for future upgrades, making it a cost-effective and scalable solution for industrial automation.